So we're going to graph this demand curve. And we're going to graph inverse demand. Inverse demand is P as a function of Q. But, so normally we would take this and then we would just solve for P. But I got this problem here, and it's this other variable. I can't graph things in three-dimensional space, so I need to just get the relationship between price and quantity demanded, and I need to get rid of this PY. Well, I'm going to hold it constant, and I'm going to hold it constant at its current price. So I got Q is equal to 850 minus 50P minus 3 times the price of Y, but we know the price of Y, and it's 10. So we have Q equals 850 minus 50P minus 30. So Q is equal to 820 minus 50P. Okay, this is the demand curve. But I want the inverse demand curve because that is what I'm going to graph. So now I'm going to solve this equation for P. So I'm going to add 50P to each side. So I get a minus 50P plus 50P. That 50P goes away. I am trying to solve this for P, so let's subtract Q from each side. And then I'm going to divide everything by 50. 50P divided by 50 is P. 820 divided by 50 is 16.4. And then we get 1 over 50 times Q. And this is the equation. This is the inverse demand curve. P is a function of Q that I want to graph. Okay. So when I graph, I like to look at the intercepts. The first one is easy. If Q is equal to 0, then this whole bit will go away, this right here, and we'll get P is equal to 16.4. So I know my maximum point on the demand curve is going to be 16.4. Then I need the other intercept, so I want to have if P is equal to 0, then I get 0 equals 16.4 minus 1 over 50Q. 1 over 50Q is equal to 16.4. Then I'm going to multiply both sides by 50. 1 over 50 times 50 is 1, so I get Q is equal to, and 16.4 times 50, we already know it's our 820. Because we could also, because we had this demand curve, I could plug in 0 for P right here, and I would see 820. So I got my demand curve, my inverse demand curve. I want to provide an example of a change in price that leads to a movement up the demand curve. Okay, well, if I want to move up the demand curve, I'll pick some random point A, and I want to go to some other point B. So in order to do that, what happens to price? Well, if we go to A to B, our change in price has to increase. So let's just pick 2 prices, right? It just says provide an example. So we can do that, provide an example. Let's see what happens if, so I'm going to use P equals 10. If P equals 10, plug in 10 here. 50 times 10 is 500. 820 minus 500 is 320. So let's say this is P equals 10. This would be 320. Let's have price increase. Let's have price increase to 15. If price is equal to 15, then 50 times 15 is equal to 750. So I got 820 minus 750. And if we move up here, to 15. Then our quantity, our quantity has fallen to 70. That's a movement up the demand curve. Now we've been asked what happens if the price of Y falls to $5. Well, there's two different ways that we can look at this problem, and you can pick whichever one that you like. Now, one, we can go back up to this equation right here, and we can say, well, this -3, it gives me the change in Q as PY changes. So what this -3 tells me is that if PY goes up by $1, then my quantity is going to fall by 3. So PY went down by $5. I would expect my quantity to go up by 15. But we can verify whether that's true by starting at the beginning and plugging in our new value. Quantity demanded equals 850 minus 50p minus 3 times now. Instead, I'm going to do 5 instead of 10. So Q equals 850 minus 50p minus 15. 850 minus 15 is equal to 835. There is my new demand curve. I can solve for inverse demand if I wanted to graph it, but I wasn't asked to do that. What happens? Well, now, if P is equal to 0, Q is equal to 835, whereas before, if P was equal to 0, Q is equal to 820. So indeed, we saw a 15 increase in quantity, just like we expected. So that answer is, if price falls to $5, then we get a new demand equation. We are going to get an increase in demand, which means we want more at any price, right? And so now this is going to be 835, and we're going to get that rightward shift in demand.